Earlier times, X-ray films need to be processed in the dark room, immersed into various solutions. This was dark room chemistry. Means after exposure, the film needed to be gone into the dark room, immersed into solution, and then we could be able to see the image on the film. But nowadays, because of computer, because of CR, DR, just take an image, put it in the scanner, and we'll get the image. This was not earlier time, but we need to study. So let's today study the dark room chemistry. The radiographic film in the dark room chemistry. The radiographic film was made up of silver halide, that is silver bromide mostly, or silver iodide. So what happens? The positive silver ion in the silver bromide has an ionic bond with the negative bromide ion. During the processing of this radiographic film, means during making of this film in the lab, there are sensitivity spec created. What are these sensitivity spec? They are like an electron trap. They will attract towards them. The Dernier-Mott hypothesis explains what happens. Let's see this hypothesis. First, when the X-ray will hit the radiographic film, the silver halide will be exposed to the X-ray. What will happen? Immediately the electron will be emitted from the bromide ion. What happens? The sensitive spec are the electron trapper. They'll attract electron. So when electron will be emitted from the bromide, it will directly go towards the sensitivity spec. This then becomes, the sensitivity spec then becomes negatively charged. So positive silver ion then will go and attach to this negative sensitivity spec, picks up electron, becomes neutral silver atom. Therefore, this will form the latent image which will appear black. The area where the X-rays have interacted, it has formed the latent image. But what happens when the area where the X-ray doesn't interact? Then the silver bromide ion in that area where it doesn't interact will not be affected, but it can cause blurring of the image. Therefore, they need to be removed, and this is removed by ammonium thiosulfate. This is known as a fixing agent. Therefore, this will prevent fogging. Now let's see the steps. First step is development. What happens in this? What are the material used? We use a reducing agent. What is a reducing agent? Hydroquinone and metol. What does this do? This reducing agent helps sensitivity spec to rapidly trap more and more electrons. Therefore, more it will become negatively attached the silver and this. Second development agent we use is alkali, which is sodium hydroxide, to prevent fogging. And third we use is antioxidant, which is sodium sulfide. This will slow down the oxidation. The second step we use is rinsing by acetic acid to neutralize the alkali effect. Third step is fixation. How do we fixate? We fixate by using ammonium thiosulfate. This will remove the unexposed silver bromide ion which we had previously discussed. Fourth we use is a fixer neutralization to remove any residual fixer agent present, that is ammonium thiosulfate. Fifth is washing. Sixth is drying. The minimum time for process is 40 minutes, and as the temperature will increase, the development time will also increase. Therefore, this darkroom chemistry is also known as a time temperature Method. This is a dark room where the whole procedure of making a X-ray is done. Now let us revise. As you can see from the image, we can see there are multiple containers. Now each container will have different substance. Like there will be one container for development, one for rinsing, one for fixation, neutralization, one for washing. So each process has to be done, means the X-ray needs to be dipped in development container for some time, remove it, put it in the rinsing container, keep it for some time, remove it, then keep it for fixation, neutralization, like this, so on. So we'll revise how darkroom chemistry occurs. We have radiographic plate made up of silver halide, out of which the silver ions have been bond with the bromine ion, and during this making there is sensitivity spec, which is a electron acceptor. When the X-ray will hit this silver bromide, electron will be removed from bromine ion, goes to sensitivity spec as it is electron trapper. This positive silver ion will go towards sensitivity spec, picks up electron, becomes silver atom, forms the latent image. Now how to achieve this? First step would be, we will keep this radiographic plate in the development. Development will have reducing agent, that is hydroquinone and metol. What does this do? It will help sensitivity spec to rapidly accept electron. Therefore the process would be rapid. Second would be alkali, sodium hydroxide, which will prevent fogging. Third is antioxidant. Since we have used alkali, we need to rinse it, so we'll keep it in the second container, which will have acetic acid, which will neutralize the alkali. Third step is fixation. Now some silver bromide will not be exposed to X-ray. This will have detrimental effect on the image quality. Therefore we need to remove it. This is done by ammonium thiosulfate, and this process is known as fixation, which is the third container. Then we'll keep in the fourth container, which is fixer neutralization, to remove any residual fixer present. Third, we'll keep in the water to wash it, and then we'll hang it to dry it like the image seen on the right side. This is the process where in the dark room earlier times X-rays were made on the plate.